What's up, Eastview Scholars? Welcome to my backyard for this edition of Sharp Shorts, a little video tutorial series to help you in class understand some of the basics and give you some background on what we're doing. Today we're going to talk about chemistry. Why am I here? Why did I take this class? What's wrong with me? And what is the scientific method? Let's start with the chemistry. Chemistry is essentially called the central science, and it's, if you talk to a chemist, they will tell you that all the other sciences work off of this one. Why? Because chemistry is a science of matter. What's the matter, you ask? What's the matter? Matter is everything. Matter is anything that is defined as anything with a mass and a volume. So it's this beautiful Adirondack chair I'm sitting and enjoying in my backyard. It's the tree behind me. It's the wood chips I'm sitting on that are part of my garden. It's the little birdies that are going to be flying around the back of my head. You might be able to hear through the microphone. It's the lunch I just ate. It's in my spectacles. It's the bug that's biting my foot right now. It is everything around you. It is the air that I'm breathing, although you can't see it. It is made up of atoms. And those atoms build matter. And so whether it's organic chemistry or physical chemistry, or it's anatomy and physiology or biology or physics, they all have a basis in matter. And so that's why chemistry is a central science. Our study this year will be to look at that matter, first of all define what it is, and then look at its interactions. That's really what it is. The scientific method then is really that process. It's really more of a procedure. Science itself is really a process for understanding nature and its changes, like we just talked about. The scientific method is a procedure right at the center of that scientific inquiry. I'm making observations of the world around me. I want to know why. And the best process to follow then is to come up with that question. Then figure out a way to test that. Come up with a hypothesis, a statement, a testable statement that says, I wonder if I can do this and figure out something along that line and do a little test and see if I can answer this question. Then you experiment, you collect your data, you analyze that data, and then it depends on what happens. If your data is following your hypothesis, then you can start recording it and developing a theory. If your data is partially or maybe not completely or at all supporting your hypothesis, then you swing back and you either reform your hypothesis or tweak your hypothesis, your experiment that you designed or something along that line. You collect more data. And you do this over and over and over again. No theory has ever been developed, or no scientific law of any type, which is different than a theory, we'll talk about that at another date, has ever been done without large quantities of experimentation and data collected to see that that hypothesis holds true. So in the beginning of our class here, you know, the scientific method is nothing new to you. You've been in science before. You've done this work before. What I would say to make us stronger and better prepared for college or AP Chem or the next class that you take is that A, we work on writing your hypothesis, which is generally a little weak at this time of your education. A nice if-then statement that is testable. And then developing experiments to understand what independent and dependent variables are. And then the key component that will help you in any type of life, any type of exams, but especially in lab reports, science exams, standardized exams like the ACT, and even in college, when you get there, is that analysis of the data. That is just something that you haven't had to do at great length to this point. Okay. And then next, let me show you some definitions here. Let me click to the next slide quickly. And here we go. I've got some definitions. This is what I call fill the bucket. Fill the bucket means you're outside reading and watching these videos and things along that line that just give you basic stuff. We don't necessarily need to lecture on. You can get this stuff, fill the bucket at home, and we will fill that in later as we work together to really work on your processing skills. The first one there you see is observation. Observation is the first thing that may have given you a question that you wanted to test and do on a hypothesis. It is also a key component in the experimental phase. And that observation, just use your senses. Be aware of what's going on. There are two types of data really you can collect. You can collect qualitative data. The sky is blue. Things that you see and observe, smells, sounds, taste to some extent, although to quote my favorite lab guy, Don Showalter, in the lab, we don't taste, we test. So those are things that are not things that you have measured and given a number and a unit to. And they are just as valuable to tell you, the difference between a physical change and a chemical change, or things along that line. The other type is a quantitative observation or quantitative measurement, which is something you actually measured, whether it's a mass or a length or a volume or something along that. You have measured it with some tool that will give you a number and the units that go with it. One thing to be careful with observation of any type: avoid assumptions. Really, you have to turn off your brain to previous knowledge most of the time. But you don't want to start making assumptions and believing you know an answer before you've tested it. That then goes away from actual being part of the scientific method. The next thing is a hypothesis. We know what that is. It's a testable statement to answer the question I have. Generally, it's in an if-then statement. If I stayed out till 3 in the morning and then came home, then my wife would kill me. That's very true. I don't need to test that. Okay. Then you experiment. In experimentation, you have two variables. You have the independent variable. That is the variable that you are changing experimentally. Okay. And the dependent variable is a variable that responds once you do that independent change. Let me give you an example. Say you're going to go scuba diving and you have this new tank, or maybe you're a scuba tank tester. And somebody designed this new tank to go into great depths of the ocean. Scuba tank is an enclosed tank with gas in it that is pressurized, and that will change with temperature. So you design an experiment where you will, without diving deep into the ocean and being at a point where the tank fails and you die, you will go into the lab and you will take that tank with that enclosed gas under a set pressure, and you will then change the temperature. Changing the temperature is your independent variable, and you will then test the pressure at those different changes. That was the dependent variable. Okay. And the last thing to mention there is just a theory. Sometimes you can use the term model. We will, when we talk about the atom and atomic models and how they developed from Dalton up until the quantum mechanical model of today. All those are is after you've tested hypotheses a number of times, and it gives an overall explanation of the natural phenomenon. Then you can call it a theory or a model that works with. And again, those things aren't necessarily set in stone. As we will talk about using the atomic models as an example, starting back in a certain time period, many of these theories lasted for 100 years, 50 years, 100 years before somebody, technology improved and things improved and they were able to continually test the hypothesis and things started to change. Okay? So that's it for this edition of Sharp Shorts. Hope you enjoyed my backyard as much as I did. Go on and scholar on, Eastview kids.